Good morning, friends. In this video, I will explain the programming of microcontrollers to send the weather data to Thingsboard dashboard and to view it on the web server. So here is the operational flowchart, and as you can see, first step is to connect to the Wi-Fi. Then, if the Wi-Fi is connected, then next step is to connect to the MQTT broker. This is the Thingsboard server actually, and once MQTT is connected, measure the weather parameters, all the temperature, humidity, pressure, etc., and then make a dictionary of the telemetry data. It's in JSON format, and then publish the data to the MQTT server, and then wait for 10 seconds. Then again repeat the process, measure and transmit again. So keep doing this until there is an error. If there is an error, then try to reconnect. Now, if the reconnection retries have been exceeded, then stop. Otherwise, if there is a power failure, then it stops. So that is the only two stopping criteria. Now, if we choose a Raspberry Pi IoT client, we can program it in Python from Jupyter. And once configured the IDE, we can convert the program into a script so that it can run on system boot continuously. But in case of microcontroller, every time the microcontroller starts in the Arduino program, there is this two parts, setup and loops. So it will enter the loop, and this is basically loop, the whole thing. So it will keep executing indefinitely as long as power is supplied to the microcontroller. So here is the program. So we have to include the library. So this library provides the it is said like it says web server, but it also provides the Wi-Fi access client as well, and we need that to make our microcontroller as a client to connect to the Wi-Fi access point as a client. Then Thingsboard.h, this will provide the necessary libraries or functions to send data to the Thingsboard server we have created before. Then this token, we have to copy this token from the backend of the Thingsboard API from the web server. Now, once we now this token will be it depends for every device you create, and depends on your instance, so it is a secret. And then this Wi-Fi API, you have to add your Wi-Fi API name of the Wi-Fi API, that access point that you have, and password you have to set the Wi-Fi password. Then we instantiate or initialize this or define this client, Wi-Fi client. Then we define this Thingsboard size, the JSON buffer, how much data we want to send. Then Thingsboard server, you have to define this name of your Thingsboard server. Now in this case, mine is this on my domain, on this subdomain. Now in your case, it will either be localhost if you have set it up in your localhost, or you can send it to your own server. Then we can start Wi-Fi begin this thing. So it will instantiate your Wi-Fi client instance. Then you have to include some these sensor measurement values, the sensor library, so that we can measure our sensors. Adafruit sensor is for your Adafruit BMP280H and DHT sensor, etc. So this one is Adafruit's unified sensor library, so it needs to be present to use any of the Adafruit newer Adafruit libraries. Then we instantiate our this is our BMP280 pressure sensor. So this is I2C bus. Then this one is DHT sensor, the DHT pin to which the sensor is connected, and the type of DHT sensor. So that way you can instantiate this one. Then we declare our variables to store the values from the sensors. Then these are pressure and sea level pressure, again more variables. Then we declare our own init Wi-Fi function, initialization for Wi-Fi. So these are some useful debugging commands so that we can see in serial terminal like the progress of Wi-Fi connection. Then Wi-Fi begin. These are pretty standard use of the library, so you can also find them in the library's documentation as well. Wi-Fi here, you keep checking whether the Wi-Fi wireless is connected or not. If it is not connected, then wait for 500 milliseconds. and then try again. So keep trying it until the Wi-Fi is connected. Once it is connected, then it will return a status code, and that way we can say it's connected to AP. Now here is the setup part. So this bunch of code or these lines of code will run when the microcontroller resets or it starts up. So we initialize the wire. This is the SDSL I2C bus. Then serial begin. This is our baud rate at which at this speed we will be communicating with our computer for debugging purpose only. Now once you see that your program is working, then we can remove all serial begin or serial print statements from it to like save some memory. Delay 100, give it a little 100 millisecond delay. Then here again check whether the BMP is initialized properly, because many times this sensor fails to initialize, and if it fails, then later on when you try to read it, it won't work. So that is why initialize the BMP and wait till or process the error. So for example, if there is no error or this address is different, then it will print this error message so that we can debug accordingly. And if it is initialized, then proceed. DST begin, again we initialize the DST sensor. Init Wi-Fi, the previous code that we saw, we initialize or we connect to the Wi-Fi. Then after we connected to Wi-Fi, you can print the IP address, local IP address, and here you can print the local IP address. And this variable will be used to determine whether we have sent the data or when we have sent the data. Now this is my long function name, which basically reads the temperature. If you remember the flowchart, we read the temperature, humidity, and pressure from the sensors. Now this part we have already shown in the previous video. And again, this clause, it will this particular function, it will try to see if the sensors were read correctly, the humidity and temperature sensor. If not, then return and try again. Now here it will print sending data to Thingsboard. Then it will so these serial print terminal or commands, they will show in the serial terminal or UART terminal that is in your computer, so that you will know, okay, it's working. Then this is these are the this is the dictionary. We need to build it in a dictionary form and send it as send telemetry data. You can also send individual items, but I found out that this method is more reliable than sending individual items. So, and also when you send the whole item, then you can also save the time at which they are received as the timestamp. So all three items will have the same timestamp. So it becomes easier to query the data later on. So we compile all those three variables, temperature, humidity, and pressure. I am sending only these three. So as a dictionary, and then I will send it like this. And here is the reconnect program or reconnect function. So this just checks whether the Thingsboard API is connected. If it is connected, then fine. If it is not connected, then check again whether the wireless is connected. If wireless is not connected, then try to reconnect. So this is what it does. Here is word loop. So in this loop, you just check whether Thingsboard is connected. If it is not connected, then reconnect. Now if here is a non-blocking delay program. So basically we are counting the milliseconds. The millisecond, there is an internal timer in the microcontroller which counts the milliseconds. So we just count the milliseconds, and if the millisecond, the measured milliseconds between the last time we measured and the previous the current time is greater than 10,000, that is 10 seconds, then only we send the data. That means on the server side we will be receiving the data every 10 seconds. And we keep loop. So this tb.loop, it loops this whole thing. So here you can see the debug side. So first it tries to connect to the Wi-Fi. So this is my local IP address that it got, that our NodeMCU 826 microcontroller got. And once it got, it tries to connect to the access. It's done connecting to the access point. Then here connecting to the Thingsboard node. This is the next step. Sending data to the Thingsboard. Here it will start sending the data at every 10 milliseconds. So this is a recorded GIF animation from when it was being debugged. So temperature, humidity, pressure, these three data we are sending. So and when it is typing sending telemetry data, it is actually sending the data to the Thingsboard server. So this thing will be repeating as long as the power is on. Now on the server side, you can see this data. For example, this was the particular date. So you can see this data, there is this 10-second gap between each of this data. So, and you can also see they are like changing because it was also a recorded animation live. I will in the next slides, I will show you the actual data. We will switch to the Thingsboard dashboard and you can see them. And the dust sensor, similarly, this is another a separate NodeMCU 8266 microcontroller that was configured to send the dust sensor data. Now, of course, since in this particular program we did not use any analog sensor, you can combine them both, or a single microcontroller can be used for both of them. But I did not want to disturb this one, so I tested the dust sensor with a second sensor, second ESP8266 microcontroller. Now this is the dashboard which has been configured. So you can see this temperature data that has been gathered and humidity, and here on the left side you can see the wireless telemetry. These are the tables or different data. Here you can see there are two different instances of ESP8266 who are sending the data. The first one sends temperature, humidity and pressure. The next one sends the dust values, and on top you can see this here on the bottom, this barometric pressure sensor BMP280, it is not working very well. That is why you see all those many times it crashes and this thing changes. It should be around 9000 in this location, but it's about almost 13,000. So this one is wrong. And here you can see this humidity. Humidity is okay because this for last couple of days it has been quite humid, so that's why you see 100% humidity here, relative humidity. And temperature also, it's working perfectly fine. And on this side, on the top right, you can see the dust density. So it's always remains around 100 to 150 micrograms per meter cube. So that's is also okay. Now these different type of dashboard, the front end items or gadgets or widgets they are known as. You can configure them whatever widget you like. There are many different widgets available on the Thingsboard API. Now let's switch to the IoT dashboard where you can see the real-time data. Here is the real-time data right now. So today is 21st August and you can see this this time. So 7:41 AM, this is right now in the morning. And we are receiving this data, temperature, humidity, pressure, and also from this dust sensor data you can see it's approximately 143, 149. It keeps changing and it's always around 150 microgram per meter cube. And humidity, as you can see, it's still reaching 100% humidity for most of the time. And barometric pressure sensor, as I said, this sensor it's faulty. It's not working very well. So you may need to choose a better pressure sensor than BMP280. And here temperature, this sensor works perfectly. This temperature reading I am reading from the humidity sensor itself. So this one works perfectly fine. From last couple of days the temperature has dropped by 4 degrees. As you can see, here it was 36 and now it remains below 32. It's approximately 31 the highest and 20. It's only 4 degrees variation throughout the day. Now it's this is Raurkela, Odisha's weather station. So yeah, so accordingly these things, these parameters are like that. And here is temperature and humidity. Okay, I have displayed them as a gauge. Now you can change these parameters to make it look better. The input and the minimum and maximum values of, because each bit you see here is editable. You can edit them by going to the here this management console. Here you can go to this dashboard and I have created a few dashboards. Okay, I have to sign in again. Here are the dashboards. The one you are seeing here is Chend Raurkela weather station. So this one, you can click this edit button. Open dashboard. Now here will be this edit button on the below. You can click it and each of these gadgets, they have their many different parameters. For example, in this one, if we edit this, then you can see this advanced settings or just settings, colors, the names, and here is this minimum 5, maximum 60. So maximum it will never reach 60, so I can change it to, let's say, 50. Minimum is 5 is fine. It never reaches 5 here as well, so I can set it 10. There. Now you can see it has changed from 10 to 50. Obviously now this, as you see, this value changed, so this color level, so then you have to again adjust if you are changing anything. So these are the values, so you have to change them so that they match up with this lower and higher one. Here these are the values, so they were written from 5 to 15. So now I have to change this one to, let's say, 10, and the top one, the highest should be 50. So you can just delete this, these two, and click OK. It will look little better here from 10 to 50. So this is how you can configure your dashboard to show these values, and once the dashboard is ready, you can make it public. So go to the dashboards, and here, for example, this dashboard, I can just click here, make dashboard public, and this is the public link. This public link you can give to your clients or whoever wants to watch the dashboard, but they will only able to see it, but they cannot edit it. For example, this is the public link, so there is no edit button here. This is for other people to see it and get whatever useful information you want to convey them through your IoT system. So that is all about building an IoT weather station. In next slides, I will discuss maybe different services which we can use to deploy the same type of IoT weather station or any IoT system, such as Microsoft Azure and the Amazon AWS or ThingsPeak and ThingWorks, etc. Thank you for watching the video, and I hope to see you again in my future videos.